on how you would go about finding the leading term. That leading term is going to give us a lot of information. So we're going to find leading term, find the degree from it, the maximum turning points. That says max TP. When you use TP, take it to the max. That's not what that means. This is finding the maximum number of turning points that you can have in a graph. We're going to find the end behavior, then y-intercept and x-intercepts with their multiplicity and whether they bounce or touch the x-axis and whether they cross. So how we find the leading term is we look at every one of these factors, every one of the factors, including that coefficient, and we multiply the highest power of the variable that we would get if we were to distribute it. What that means is we take -2. If we were to distribute this, there's no exponent here. We would only get x to the first power out of that factor. If we were to distribute this, we would actually get an x squared out of that factor. Remember that this is not as simple as saying, oh, x squared plus 1/4. That's not what we're doing. What we would have to do to distribute is x plus 1/2 times x plus 1/2. But if you think about that, if you were to distribute that, you would get x squared as your largest power of x. And upon distributing the whole thing, you really would get just the largest powers of x that you would obtain in order to find your leading term. And that's what we're doing here. So you'd say, all right, if I were to distribute this, my largest power would be x squared. Here, if I were to distribute this, I would get x plus 4 times x plus 4 times x plus 4. And if I were to distribute the whole thing, my largest power of x I would get would be an x to the third power. So is it as simple as just taking the exponent here and multiplying it times there? Yes, it is. Now, you can't distribute that way, but that's what we're going to end with. Our last one, if you were to distribute that, that's x squared plus 9 times another x squared plus 9. X squared times x squared, let's see, 2 plus 2 is x to the 4th power. Yes, you can multiply 2 times 2 and get 4. These are all the largest powers of x that we would get from every one of those factors if we were to distribute it. And distributing the whole thing basically comes down to take your coefficient, whatever it is, multiplied by all of the largest powers of x. Coincidentally, it's 1, 2, 3, and 4, that you would get, and remember to add the exponents here. So let's see, 4, 5, 6, 7, 8, 9, 10. That's -2x to the 10th. I guarantee it. If you take the time to fully distribute this, two things are going to happen. You're going to spend about 10 minutes. You might make some mistakes in there, because I know I do when you have that much to distribute. But secondly, you're going to end with a leading term that is -2x to the 10th, for sure. That's really all you need to know from distributing this on what you're getting. That's it. That's the only reason to distribute it, is to find your leading term and your y-intercept. I'm going to give you some workarounds. The first one I just gave you is pretty nice. So our leading term is -2x to the 10th. We're going to use that to find out several things about this. Number one is the degree. If you remember, the degree is the largest power of your largest exponent that you have in your polynomial. So you look at all the terms and you go, okay, what's the largest power? It should be in the leading term, the one that's right up front, because you should have written this in order. So when we look at our leading term, it automatically has our degree in it. It's 10. The reason why we want to identify the degree is because the maximum turning points you can get. Now, you might not get this many turning points, but the most you can get is always one less than that degree. And we explored that concept in a few videos ago. So you can have at most 9 turning points. Here's what that means. You can change directions on your graph from increasing to decreasing or decreasing to increasing at most 9 times. So you could go 1, 2, 3, and you can do that 9 times. So this also gives us an interpretation of our end behavior. So when we learned about power functions a few videos ago, we learned that even always kind of pairs up your infinities. It has to have that same sign in your end behavior. So evens either do this if they're positive evens, or this if they're negative even power functions. And because our end behavior is based on the power function that we get from our leading term, that leading term will tell you your end behavior. This says the 10 is an even power function. That's like this. But the -2 says, yes, but that would be reflected and probably a little narrower because that coefficient in absolute value is greater than 1. And that's what determines the narrowness or wideness of your graph, that vertical stretch or vertical compression. So again, we think about it, we go, all right, That says even. Sure, that means that we have either upward opening completely, positive infinity, or downward open, negative infinity, negative infinity. So we look at that and go, that's even, but that's negative. So that makes a end behavior that would do this, sort of a downward opening graph if you kind of zoomed out a long way. So we're going to draw like just a little picture of that. Our end behavior should be pointing downward as we get to x approaches negative or positive infinity. It should be doing this. And it's going to be doing it very steeply because of that power and because that's a -2. So it's going to be very dramatic.